All right, let's talk about something in JavaScript that seems so simple, but it trips up pretty much everyone at some point. And that is what really happens when you try to copy an object. I'm telling you, if you can get your head around this, you are going to save yourself from some of the most frustrating, subtle bugs you can imagine. So let me just ask you this straight up. You got an object, you assign it to a new variable. What do you have now? Are they two totally separate, independent things? Or is there something a little more sneaky going on under the hood? Okay, let's look at some actual code. Super simple. We make a user object and we give it a name property, John. Then we create a new variable, admin, and we just say admin equals user. Easy enough. And for the final move, we change the name to Pete. But, and this is the important part, we're doing it through the admin variable. And now for the $1,000,000 question. After we run that last line, what's the value of user.name? Did it stay John, like you might expect, or did it change to Pete? Take a second. What's your gut tell you? And the answer is Pete. Yep, the original user object was changed, even though we only directly touched the admin variable. Now, if that just blew your mind a little bit, don't worry, you are in good company. To really get why this happens, we have to pull back the curtain and look at how JavaScript handles its data. This brings us to the absolute heart of the matter, the difference between copying by value and copying by reference. I promise you, this is the key that unlocks this whole mystery. See, it all comes down to this one simple rule. Primitive types, things like strings, numbers, booleans, they get copied by value. That means you get a brand new, completely independent copy every single time. But objects are different. They're copied by reference. You're not actually copying the object itself, you're just copying the address where the object lives in memory. So what even is a reference? Well, think of it like this. When you have a variable like user, that variable isn't holding the big chunky object data. No, it's just holding a little note. And on that note is the address of where that object is stored in your computer's memory. It's basically just a pointer. And this is just the perfect way to think about it. Imagine the object is a file cabinet. The variables, user and admin, they aren't two separate cabinets. They are just two different keys to the exact same cabinet. So it doesn't matter which key you use. If you open it and change the files inside, you're changing the contents of that one single cabinet. Okay, so the theory makes sense, but what does this actually mean when you're writing code day to day? What are the real world consequences of this whole reference thing? This is where it gets super practical. First up, comparison. When you have two variables that point to the exact same address in memory, like B pointing to A here, JavaScript says, yup, those are equal. They're not just similar, for all intents and purposes, they are the same thing. But, and this is a big but, what if you create two totally separate objects? Even if they look identical, like these two empty objects, well, they each get their own unique address in memory. So when you compare them, JavaScript says, nope, not the same, and you get false. Okay, this leads to another classic point of confusion. We declare an object using const, and we all know const means constant, right? Unchangeable. So what happens if we try to change a property on this const object? Is that going to throw an error? And the answer is no, this code works perfectly fine. And here is the big aha moment. The const keyword only protects the variable's value. And for an object, what's its value? It's the memory address. So const just means you can't make the user variable point to a different object. It says absolutely nothing about changing the stuff inside the object at that address. So if a simple equals sign doesn't actually make a copy, how in the world do we do it? How do we actually clone an object? This is so important, especially if you're working with frameworks like React or Vue, where changing state directly is a huge no-no. So let's look at how to do this the right way. Our first stop is something called a shallow copy. The basic idea here is simple. We're going to create a brand new, totally empty object, and then we're going to loop through the original and copy all of its properties over to our new one. Now, a really easy way to do this is with a built-in method called obj2. All we do is give it a target, our empty clone object, and a source, our original user object. It then just copies over all the properties, and boom, you've got a shallow copy. Now, that works perfectly for simple objects. But you knew there was a but coming, right? What happens if one of our properties isn't just a simple string or number? What if a property is an object itself, like this sizes object nested inside our user? And this is the trap of a shallow copy. It copies the top level properties just fine, but any property that is also an object, well, it just copies the reference to that nested object. So our clone and our user are now sharing the exact same size as object. If you change the height in one, it's going to change in both. Yikes. This big limitation with shallow copies brings us finally to the real solution, the thing you'll want to use 99% of the time, a deep clone. So what is a deep clone? Well, it does what you'd expect. It doesn't just copy the top level stuff. It goes down recursively through the entire object and makes a brand new copy of everything it finds, including every single nested object. The end result is a completely independent, totally unlinked duplicate. And here's the best part. In the old days, you had to use libraries or write your own complicated functions to do this. Not anymore. Modern JavaScript gives us a beautiful built-in method called structured clone. You literally just pass it your object and it does all the hard work for you. It's fantastic. Now, structured clone is crazy powerful. It handles nested objects, arrays, even really tricky things like circular references with no problem at all. The one major thing to remember is that it can't clone functions. But for just about any kind of data object you're passing around, it is the perfect tool for the job. Alright, so let's boil this all down one more time. The number one thing to remember: objects are copied by reference, not value. That one fact explains why comparison works the way it does and why you can change things inside a const object. If you need a quick, simple, one-level deep copy, object.assign is your friend. But for a true, completely independent duplicate, structured clone is the modern way to go. And that brings us to the end. I want to leave you with a question to think about. Now that you really understand this difference between a reference and a real copy, where in your own code, right now, might a shared reference be causing a subtle, hidden bug you haven't found yet? Go take a look. Thanks for watching and happy coding.